Alright, this is recording. And I sent my calculators, all three of them, or four of them, to school with my daughter today. And so I'm going to be calculating with Wolfram Alpha. Now, what you'll see here is this is not just happenstance. As I've been working within Mathematica and talking about some of the other mathematical engines that are just there. They're on your iPod Touch. They're freely available on the web, and they are advertising for over 50 jobs for this company. The free version on the web does do vector calculation using standard Mathematica format. So I'm going to show that to you when I go through this process of adding up the moments of the forces on the problem that we're looking at, which has four non-concurrent forces on a structure. First, however, I don't have a calculator, and so I, of course, have already sketched it out, but I can learn to put basic formulas into Mathematica. For instance, that first one, we ask it a question we usually know the answer to, 100 times the sine of 45. We should know the sine of 45 sooner or later, and I guess we usually want to put in degrees when we do something like this if we don't know the answer. In addition to knowing the tangent, we know that then the first force is going to have components of 70.7 in the x and in the y. The second force, if we look at it, which was 50 kips at a direction of 110 degrees, had components of minus 17.1 and plus 47, more or less. 200 at a direction of 253 had components of minus 58.47 and minus 191.3. And the last one, 150 kips at 305 degrees, is 86.04 in the x direction, minus 122.9. At this point, breaking things up into x, y, and even z is something you need to be able to do. And I was kind of interested looking around for the conversion program within Wolfram. I didn't find it. However, I did find something else. And the reality of, once you understand that doing a cross product is as basic of mathematics as 453 by 674, you then search for the most efficient engine. And here I will show you a pretty darn efficient engine. And that is, if you type in CROSS, open bracket, open parentheses. And our first vector was 4 in the x, 5 in the y, and 0 in the z. Close the squiggly bracket, comma, open squiggly bracket, and our force vector is 70.7, comma, 70.7, comma, 0. Close squiggly bracket, close hard bracket, hit an enter, and it gives you, not only does it give you the calculation, I think, it gives you the resultant and a picture and everything else. And so you write down that it has a moment of 0, comma, 0, comma, minus 70.7. So that, in effect, is your first moment. Now let's double check that it makes sense. Our vector was 4, comma, 5, comma, 0, and the other one was 70, comma, 7. It's kind of odd that it turns out to be that way, but it does. And we can look at graphically why that is. I presume it is because of the way that vector breaks up. But we can now write that one down and move on to the next vector. The next vector being, just go back right up to here. And then if you could write this out, if you had the full program, you can write them out in a series of steps. So you can kind of look at what you've done. I don't believe that's possible here, though someone else can prove me wrong. I'm going to go here and calculate the second cross product, which is 10. I'm kind of trying to walk up. Ten comma 0 comma 0, and in this case we said it was minus 17.1 comma 46.98 comma 0. And when you hit the calculation or hit the return here, you should get an answer. And this time your cross product vector, and it's showing here. You notice how large that becomes because, again, when you multiply vectors out, the magnitude of the moment is going to be the area of the enclosed by those other two vectors. So the second moment here is 0, 0, 469.8. That was for the one out at 10 feet. You can go through that process. I'll do that, finish it out here. But once again, realizing that these are standard mathematical calculations, and what is standard quickly changes with technology. 58.47, and then 1 minus 191. And in this, I would find the justification, minus 91.32, next year, have everyone get an iPod Touch, because this is available on an iPod along with much other things for something like 49 bucks. So this is my third vector calculation. And the problem with, as always with doing stuff like this, is in fact 0, 0, 1530.4. is that you can't see all your calculations out in front of you. And the last one here we have is then 0, minus 4, 0, and our vector here is 86. 86.04 and minus 127.9. Now, if it was only for this calculation, this was not the only reason to look at Mathematica. There's going to be a number of other things it can do in terms of adding those vectors as we do it, but I'm going to go ahead and hit equal here. Since we've programmed the calculators, we'll continue to use them, but we have this now as a 344.16. So as you add those up, and going backwards, you add those up and you get the sum of the moments. You, of course, can also add up the vectors, and I'll finish with that. I'm kind of looking at my time here. I am looking at, in the order of coming up, I'm going to just add a couple of the 4 vectors that are the forces, and you can do that with, in brackets, 70.7, 70.7, 0 for your first force vector, plus open the squiggly bracket. And of course you have minus 17.1, 46.98, 0. I'll just get 3 of them done before I run out of time. Plus open squiggly bracket, minus 58.47, minus 191.3, 0, close squiggly bracket. You don't have to use an equals, you hit it right there, and it added up those 3 vectors. So in that you see, it's temporarily unavailable, try another server. That process there is what, and there's your answer, and you see there you actually get the length of the vector. I don't think it gives you, it actually gives you the angles of the vector as well. So in that you see the world is shifting around you. You better shift with it. And we'll use this the rest of the semester as well as calculators to do vector products and mathematics. Thanks for listening.